Hello and welcome to today's math lesson. So we just finished Module 3, and in Module 3 we were talking about proportional relationships where we had a constant rate of change and it was proportional. So every time we found that k value, that constant to proportionality, we did y over x. And they were always the same number. That's what made it be constant, so that we had a constant of proportionality. And what happened was every time we graphed any of those lines, they went right through the origin. So for something to be a constant proportional relationship, it had to have a constant of proportionality, so whenever we took y over x, it was the same number, and it went through the origin. So let's look at today's learning target. So today's learning target is I will be able to represent linear non-proportional relationships. So what we were doing in Mod 3 were proportional, and now starting in 4 here, we're going to be talking about non-proportional. So let's read here. Essential questions. How can we use tables, graphs, and equations? Tables, graphs, and equations. So when we were doing proportional relationships, we did things like this where we had a table. We did things like this where we had a graph. And remember, for the graph, it was fairly easy because it went through that origin. And we represented things as equations where we wrote y equals kx. So we're going to be doing the same thing, but we're going to be talking about non-proportional relationships. So let's look here at example 1. We can always use an equation to describe the relationship between two quantities in a real-world situation. So in this example 1, it is giving us the equation y equals 3x plus 2, gives the total charge for one person to rent a pair of shoes and bowl at Baxter Bowling Lanes. So if any of you have ever been bowling, you will know that they do not allow you to just go onto the floor with your normal shoes that you walked in. So if you had heels on, or if you had any kind of even plain old tennis shoe, they do not let you walk onto the bowling lanes. And the point of that is that you could have rocks or sand or things in your shoes. And when you bowl, you actually want to be able to slide a little bit on that lane, and they give you bowling shoes. So in this situation, when they have this equation, y equals 3x plus 2, let's look at this little chart right here. Baxter Bowling Games, they're charging you $3 per game. And then whenever we have something that says per game, we don't know if you're going to bowl 2 games or 3 games or 4 games or maybe just 1 game. But per game, that's why we're going to write 3x, and this x is the variable. So maybe you and your brother want to bowl 2 games, but your mom is only going to bowl 1 game. Okay, and $2 shoe rental. So it's $2 for you and your brother to rent shoes, but it's also $2 for your mom, even though your mom's only going to bowl 1 game and you're going to bowl 2 games. So we do not have an x after the 2. And you'll notice up here, that's why we have the plus 2, and this is the cost per game. All right, so let's fill in this. If you're going to bowl 1 game, like your mom's cost, okay? So if your mom's going to bowl 1 game, we're going to plug a 1 in here for x. So we're going to go 3 times 1 because your mom's cost is going to be 1 game, $3 plus 2. So your mom is going to pay $5. Now you and your brother are each going to bowl 2 games. So if you're going to bowl 2 games, we're going to take 3 times 2 because you're going to bowl 2 games. They're $3 a piece. Plus, you need to add your shoe cost. So you're going to pay $6 for bowling the games plus the $2 for that cost of your shoes. So we get 8. Okay, now let's plug a 3 in there. So 3 times 3 plus 2 would be 9 plus 2. So we end up with 11. And then if we plug a floor in there, we end up with 14, which is this exact second chart here. So if you bowl one game, it's going to cost you $5, $3 for the game plus the $2 for bowling. Okay, so now let's just think about this, if this is proportional or not. If we were going to graph these ordered pairs, what is this going to look like? So let's graph 1, 2, 3, 4, 5, 2, that was at 5, 6, 7, 8, and we're at 3, I'm going to extend this, 9, 10, 11, and then if we go, well, 1, 5 is supposed to be over here, and we keep this going. Is this going to go through the origin? 1, 2, 3, 4, 1, 2, 3, 4, I was supposed to go up 5, so I'm going to put another line in here. So now we have to come down 1, 2, 3. If we keep this pattern going, 4, 3, 2, 1, the next number would be 0. Now remember, if it's proportional, this number down here will also be 0. So what are we doing? We're subtracting 3 and we get a 2. So 0, 2 is where this graph is going to go through. So is this proportional or not proportional? And we're going to say not proportional because it is not going through 0, 0. All right, let's look at this here. So the entrance fee for Mountain World Theme Park. So this is kind of like going to Valley Fair. You pay a cost to get in. Well, at this particular place, you pay $20 to get in, but then you also pay extra for rides and games and food. At Valley Fair, you don't have to pay extra for rides, but if you're going to play games or buy food, that is going to cost extra. So just getting to Valley Fair is going to cost you money. If you buy extra things, then it's going to cost you more money. So just for walking in, we're going to be at 0.20 because that's how much it costs to get into this Mountain World theme. Okay, so now if you're going to buy 2 tickets, so we're going to use this equation, 2x plus 20. So how do we fill in the rest of this chart? Well, they're asking us here to plug in a 2. So 2 times 2 plus 20. So it looks like we have 4 plus 20. So it would cost you $24. Okay, now if we plug in the 4, so it's going to be 2 times 4 plus 20. So 2 times 4 is 8 plus 20. This is going to be 28. All right, let me do the math for one more. So if we're going to plug in the 6, we're going to go 2 times 6 plus 20. So we have 12 plus 20. So it looks like this one is going to be 32. And all right, I'm just going to fill in this last one up here. And so if we were to plug an 8 in and do the math, we end up at 36. Step 2 wants us to plot this. So 0, 20, 2, 24, 4, 28, 6, 32, and 8, 36. Now, am I going to connect these dots? And the answer is no, because I'm never going to buy just 1 ticket or 3 tickets, or there's never going to be cost between them because they're 2 tickets for rides, $2 a ticket. So I can buy 1 ticket and be right here between, but I am never going to get less than 1 ticket. I'm never going to get a half a ticket. So I am not going to connect these. All right, so we plotted these. Find the rate of change. Finding the rate of change means we can take any 2 ordered pairs and find the slope like we were doing before in last mod lesson, where we take y1 minus y2 all over x1 minus x2. You can take any 2 ordered pairs that you want. So I'm just going to take these 2 ordered pairs right here. And remember, y goes on top. So I'm going to do 28 minus 24. And then I'm going to do 4 minus 2. So 28 minus 4 is 4. And 4 minus 2 is 2. 4 divided by 2 is 2. Okay, so now if I do the next ordered pair, or do a different ordered pair, what's happening? Is this a constant rate of change? Is that linear? And the answer is yes. It is a constant rate of change, but if we just took 20 and divided by 0, is that going to be the same thing as 24 divided by 2 or 28 divided by 4? Well, 20 divided by 0 is undefined. This one's 12 and this one's 7. So this one does not proportional, because when we do y over x, we do not get the same number. So this is not proportional. That does not mean it does not have a constant rate of change. Okay, so this proportional is what I'm talking about here for number 4 question. So it is not proportional, but it does have a constant rate of change. Let's look here. When it goes like this, isn't that 4, 4, 4, 4? So the change in y is 4. Now let's do the change in x, 2, 2, 2, 2. So my change in x is 2. 4 divided by 2 is 2. Now let's go back and look at the equation. And the equation that I have here, what number is in front of x? And that is a 2. All right, let's go on to another example here and see what we've got going on. Was there a your turn at the bottom we could check? Let's see if there's anything at the bottom here. Nope. All right, moving on. All right, a linear equation. So that's what we're talking about here. And when we have y equals mx plus b. So our proportional equation was y equals kx. And remember, k was change in y over x. Okay, when we do this, we still have a number in front of x, but we have this number here, which means we will not be starting at 0. So let's look at this chart that they have here. And you see this point right here? This is an ordered pair, 0, 10. And look at your graph. To be proportional, would it have to be going through that point 0, 0? Now it still has a constant rate of change. We can still, this is a pattern, 10, 20, 30. Well, they skipped 40 in here, but we would have a 40 if we kept this pattern going. So as long as we keep the pattern going, what is this change? Well, 10 to 14 is 4, 14 to 18 is 4, 18 to 22 is 4. So my change in y is 4. Now what is doing for my change in x? My change in x is going up by 10s. So this simplifies to 2/5. All right, let's look at the your turn here at the bottom. What are they saying? Make a table and graph the solutions. All right, so they picked numbers for us. They're saying, hey, plug a -1 in for x. So we're going to use this equation, and we're going to replace x with a different number every time. So I have -2 times +1. So what number am I putting in there? I'm putting in a -1. So -2 times 1 is 2 plus 1, we get 3. Okay, now we have to do this again by plugging in a 0. So we have to do this actually 4 different times. So -2 times +1. So I'm replacing the x with the 0. So I have 0 plus 1, and we get a 1. Next one is -2 times 1 plus 1. So we have -2 plus 1. This is why we practiced our integers, or go ahead and use your calculator, and we get a -1. And the last one they're asking us to do is -2 times 2 plus 1. So we have -4 plus 1 is a -3. Then they're asking us to go ahead and graph these. So we're at -1, 1, 2, 3, 0, 1. This is why we did the second part of our pre-lesson here. So 1, -1, and 2, -3. And if we look, is that a nice straight line? So it has a constant rate of change, but it's not going through the origin. So this is a non-proportional relationship. Good luck.